For example, let's find the derivative of this function, sine square root 1 plus 2x squared. Looks simple or complicated. Depends on how do you feel. And what's the derivative of this? Let's say we write down derivative of sine square root 1 plus 2x squared over dx, and we found derivative of this. We have, for derivative part, certainly we have a few equations. We know d sine dx is what d sine dx, d sine x dx. We know what this is. This is just cosine x. We got this based on the first principle that I just introduced. Now, how to solve a question like this? And we need to use chain rule. Let's say, because we have this function, this equation, and what's the difference between these two expressions? The difference is at the denominator. If we change denominator into this square root, and we would be able to use this equation. Then let's do that. And now we have changed the denominator into this. We have to make equivalent change. Since we now divide this rather than dx, now we have to times it at the numerator. And divide by the original denominator dx. In this case, you can see this one can be cancelled with this one, so we can go back to that. Now, what we have done is making equivalent changes. We didn't change the original expression. The answer of this still would be the answer of that. But now, after making this change, we can apply this rule. d sine x over dx equals cosine. Here, this sine x over dx, what x is? X is just a variable. It can be anything. It can be, certainly it can be square root 1 plus 2x squared. It can be, it is a box. You can fit in anything inside. Now we have fitting this square root inside. So, and what we are going to get would be cosine square root of that. So, let's say we are going to get cosine square root of this whole thing. Yeah, that's what we got from this part. And for the second part, we still don't know how to do it, and we need to use chain rule again. Before we use chain rule, I'll introduce you another equation function there. We know that another rule is dx to the power n over dx. The derivative of x to the power n, it equals n times x to the power n minus 1. To be able to use this rule, we have to make some changes here. We have to make the square root is the bracket to the power to the bracket of this to the power of 1/2, and so it will be x to the power of 1/2. To be able to apply this rule, we have to make the denominator into the same form as the things underneath the square root. So we have to do the same thing again. d 1 plus 2x squared to the power 1/2. We just rewrite this square root into the power 1/2. They are the same. And rather than divide by dx, we divide by these things in this bracket. And also we have to make equivalent change. And we have to times it. And divide by dx as well. So let's find the answer. First part we copy it. It's just cosine this part. And we are going to times this. Now we can apply this rule. What the answer is n. What n is? N is 1/2 times x. What x is now? X is this things in the bracket. The things in the bracket. And to the power n minus 1. What n is 1/2. 1/2 minus 1 would be negative 1/2. And times finally the last part, bracket over dx. Now let's write out what things in the bracket. 1 plus 2x squared. Also this part is 1 plus the same thing here. Maybe it's good to write them out. 1 plus 2x squared. So for these first two parts, we can't do anything, and we just copy them. And for the last part, what is the derivative of that? We can rewrite them. For this derivative operator, we can find the derivative term by term. We can treat this as two terms, and we find the derivative of the constant term, d1 over dx plus d2x squared over dx. And let's carry on. Same thing, copy, and what is d1 over dx, which is 0, and 0 plus what is d2x squared over dx, and these two can be taken out. It would be dx squared over dx. What is the derivative of dx squared over dx? Same thing. By this I mean this times this. And so 0 plus anything equals the thing itself, and then dx squared over dx we can find from here would be 2x. So then we will have 4x. So the final answer would be, let me write down the final answer for you. Cosine, this first thing we omitted is this one. Cosine square root 1 plus 2x squared times this 1/2 1 plus 2x squared to the power of negative 1/2, and finally times 4x. And so combine the 1/2 times 4 gives us 2. So we can take them out in front. So it's a 2, and we can put x in front as well. 2x, and then we put this bracket in front of cosine times 1 plus 2x squared to the power negative 1/2 times cosine square root 1 plus 2x squared. This is the final answer. Now let's look at another example for the chain rule. let's say find the derivative of this. So we have d for x squared plus 2 to the power 5 over dx. This is the derivative of that. It equals, and first we treat this. We change the denominator for this part to enable us to use the rules. Meanwhile, we have to make equivalent change. So for the first part, we have 5 times 4x squared plus 2 to the power 4. And for the second part, we have we can separate them into 2 terms. And let's carry on. For this part, it will give us 0, and for this part, we can take 4 out, and the derivative of x squared would be 2x, and then the answer would be 8x for this overall. 8x times this 5, 8 times 5 would give us 40, and there's another x from here, so final answer would be 4x cubed plus 2. Yeah, this would be the final answer for this one.